So today we are going to discuss about the astronomical telescope in normal adjustment and the astronomical telescope in the not normal adjustment. So this astronomical telescope is made of two lenses, mainly the objective lens and the eye lens. And in the normal adjustment, you can see that this f0 plus fe will give you the total length of the astronomical telescope in normal adjustment. So f0 plus fe equals the total length of this telescope. So if we are going to find the magnification of this, the magnifying power of this astronomical telescope, we have to get an equation for that. This is how we obtain the equation. So first of all, you can see that we have tan alpha. Tan alpha will be equal to the opposite. Opposite is going to be height and the adjacent is going to be f naught. So therefore you have alpha. And now we should also obtain tan beta equals h over fe. Now, when we have these two equations, we can name them equation 1 and equation 2. Equation 1 and equation 2. So now something we should know that is this alpha and beta are very small angles. So therefore we can write it as like this. Alpha equals h over f naught, beta is equals h over fe. Now something that we should also know is that this angle, the magnification or the magnifying power of this astronomical telescope is equals to beta over alpha, is equals to beta over alpha. So magnifying power is going to be beta by alpha. So now when we consider beta by alpha, what we get here is that h over fe and reciprocal that f naught over fe is equals to f naught over fe. Now what is this f naught over fe? So now we have obtained that the magnifying power of this is beta over alpha equals f naught over fe. What is this f naught over fe? F naught is the focal length of the objective lens. Fe is the focal length of the eyepiece. So therefore we can obtain that expression or the equation for the magnifying power of astronomical telescope in normal adjustment. And also now we should also obtain the equation for the astronomical telescope in the not normal adjustment. So when you obtain the equation for the astronomical telescope in not normal adjustment, what we got to consider is the same thing. But in here you can see that the light rays travel in a way that it will form a second image. That second image will have a greater height. So h1 will be less than h2. And in here you can clearly see that these light rays will travel like this and have an edge like that as well. So light rays travel through this point and also it cuts the axis there and they make the first image. And when the first image is formed, you can see that using these imaginary lines we have also obtained the second image. So h1 and h2. And let's obtain the equation for that. First of all, what we should know that is tan alpha equals, in here tan alpha is equals to h1. It's going to be h1 over f naught, h1 over f naught, and tan beta is going to be h2 over d. What is this d? D is the near point of the human eye. If we place a human eye here, normally we observe this, so therefore we should place a human eye. Consider that you are observing an image, you place your eye there, so your near point or your point of distinct vision is represented by this value d. So this alpha and beta are very small angles, so they will just be alpha and beta in order for us to get the equation. So when we consider obtaining this beta by alpha over is equals to h1 h2 over d times f naught over h1. So now we have h2 over d times f naught over h1, and in order for us to obtain the expression, we should do something simple here. So we have f naught over fd, we write it here, f naught over fd, and this h2 over h1, something that you should know is that in linear magnification, h2 over h1 is going to be equals to 1 plus d over fe. 1 plus d over fe. Fe is the focal length of the eyepiece. So therefore you can write beta by alpha is equals to 1 plus d over fe, and we get the equation for the astronomical telescope in normal adjustment. So in order for you to obtain this equation, this is very easy, and you should also consider trying this once again when you are free, and you can write this down as a note in your notebooks as well. So I hope this video was helpful for you, and if this video was helpful, make sure you like, share and subscribe.